Okay, we've got a concave mirror here. We're given that the radius is capital R, and the question that we're being asked here is what's the magnification of a person's face when it's R over 4 away from the mirror? And then we're asked for the location of the image, and then is the image real or virtual? So let's figure this out. Um, our object distance then is given to us as R over 4. So let's make that really clear. We've got a few things that we know. So we know that P is equal to R over 4, and we know that the focal length of this particular mirror is equal to positive R over 2. So this is a concave mirror, and it therefore has a positive focal length. So the magnitude of a mirror's focal length is always half of the radius of curvature, but then the sign of that focal length depends on the type of mirror, of course. So concave mirror, positive focal length. Cool. So we can go ahead and set up from our mirror equation, and I have on the right here our mirror equation and magnification equations that we're working with. So I am solving for my object distance. Let me just do that first of all. It's going to be equal to product PF over P minus F. And what does that give us? R over 4 times R over 2. Both of those are positive over the quantity R over 4 minus R over 2. So that's our denominator there. So what does that give us? So we'll, after a little bit of algebra there, we'll get negative R over 2. All the intermediate algebraic steps you can see in the written solutions, but you guys are good at algebra, so I'm not real worried about that. So this is my image distance here. So notice that this image distance is negative, right? So here's my image distance. It's negative, so that tells me that it's a virtual image. And in the case of this mirror, so this is located behind the mirror. So an image distance is positive when it's on the side of the outgoing light, which is what I sometimes call the shiny side of the mirror. So this tells me that the image is virtual and it's on the dark side of the mirror. Okay, so we've got that done. This question is asking us for magnification as well. So let's solve for that. Magnification is the equation for magnification is negative Q over P. So remember that that negative sign is in the equation. It always is there. And when you substitute in, I would use parentheses to make sure that you're substituting in with the intended signs. Try not to do too much of the sign management in your head. I've seen that go very wrong. So negative, and then my value for Q is negative R over 2, right? So I'll substitute that in. And that's over P. P in this problem is R over 4. And that's going to give me positive 2 as my magnification value. Okay, so what's cool about this is now whenever you figure out an image like this, always kind of pause and ask yourself if it's an image that's possible. And as you're learning about these different components, you should learn what images are possible with them. So with a concave mirror, is it possible to have a virtual image that is magnified and upright, right? That magnification is positive, so it's upright. Yeah, it is. In fact, a concave mirror, when you're really close to it, acts like what we will think of as a magnifying mirror, or like a shaving mirror or a makeup mirror. So that's where we are with this mirror when we're this close to it. Okay, that's it.